So correct me if I'm wrong, Dan. I'm having this recollection when I read about this that we had a conversation at some point about the Bristol stool chart.
Global warming because some people don't believe in it, and then soon Florida's going to be underwater, and then Disneyland will be washed away.
Welcome to Hello PhD, a podcast for scientists and the people who love them. This week, we meet the people who march for science and dive deep into the physics of defecation. Stay with us.
And we're back. This is Hello PhD, episode 72. I'm Joshua Hall.
And I'm Daniel Arneman.
And we'll discuss the human side of science and life in the lab. Dan, I have to say at the top of the show, I have a cold this week.
I hadn't noticed. It's just playing into my earphones.
No, so I apologize for the crackly voice, but the show must go on.
I'll have to insert a coughing fit somewhere so that the listeners at home can catch the germs.
I'll do my best. Dan, I had an exciting week last week. I was out in the mountains of North Carolina visiting high schools to talk about science.
Yeah, this is the DNA Day event.
Yep, this is a program I'm part of called North Carolina DNA Day, and we send scientists out to high schools all across the state.
Do the high schoolers know that they have DNA every day?
Only on this day.
Only that one day.
That's right. Super fun, though. Met a lot of cool students. Had a great time, but one of the things, Dan, that I did, I was going out to western North Carolina, and I was passing through Asheville, which is one of my favorite cities in the state, which is home to lots of great breweries, but one of my perennial favorites, Wicked Weed.
Oh, you found a way to support the ethanol section of the show on your trip.
Well, I had this big plan. So what I was going to do, because I was passing right through Asheville, I was going to swing by Wicked Weed, because actually there you can get some brews that you can't get here. So I was going to pick up something interesting for the show. So I go out of my way, get to Wicked Weed. I paid to park. They had the meters, and there's actually meters you had to have quarters for. So I went in this other place to get quarters, to put in the meter, so then I could walk over to Wicked Weed.
You didn't just stand there and try and shove your credit card into the quarter hole?
I tried for a while,
right.
but it didn't work. So anyway, finally get over to Wicked Weed, and there's a sign on the front door that they're closed for a private event until 5 o'clock, and this was like noon.
Wow.
So I was a little frustrated, but I was like, well, that's okay. There's lots of cool things in Asheville. But I pulled out my phone to see if I could deduce why they were closed. And so I searched Wicked Weed on my phone and on Google, and all these articles pop up. And I read the headline over and over again, Dan. But it turns out Wicked Weed has been purchased by Anheuser-Busch.
And your hipster credentials just got torn up and thrown away.
I literally, Dan, I read it 3 times because I thought I must be mistaken.
Did you cry on the street?
A little bit.
All right?
I'm still working through it. That was
one of your favorites, I think.
I'm still working through it. So, Wicked Weed, now a sister beer with Budweiser.
Wicked Weed, you are dead to us right now.
Well, I will say, we're not drinking Wicked Weed on the show this week.
Well, they were closed. They wouldn't even sell you their beer.
No, that's true.
They're too good for you.
That's true. I guess, well, the bad news is I'm heartbroken.
Yeah.
Okay. But
it could be good. There's a wider distribution. They're going to allow Wicked Weed to brew the same beers.
The good news is now a lot of our listeners who are at least nationwide, maybe even international, might see Wicked Weed on the tap near them.
They'll be pumping that stuff across the borders. You'll love it.
So anyway, but what we're drinking instead, Dan, this is Left Hand Brewing Company from Longmont, Colorado, and this is the Nitro Milk Stout.
I don't think we've had a stout in a little while, have we?
We haven't had a stout, and this is our first nitro beer, Dan. Have you had a nitro beer?
I have. Usually it has a little rocket in the bottom, though. The Guinnesses come with a little capsule thing.
That's a Guinness thing.
That's a gimmick, probably.
I think so.
Although this is not very bubbly.
No, that's true.
We had that problem.
That's true, but a lot of times, especially if you get a nitro beer on tap, so we should point out what it means by the nitro beer. So instead of being carbonated with CO2, it's been nitrogenated. And so these nitrogen bubbles tend to be a little finer, and I think it imparts a little more of a creamy foam on the top of the beer, wouldn't you say?
I would say so, yeah. I'm waiting for the kryptonated beer or the neonated. Why not? There's neon beer. Yeah, well, there's a different beer.
So what do you think of the nitro stout?
It's really smooth, and it is it is milky somehow. Is that why they call it that?
Yeah, I think a lot of these milk stouts, they actually have milk protein
Oh, is that right? So
Yeah.
to
Or not milk protein. I'm sorry. Not milk protein, but like
whey protein, so we can just like
I'm
drink a couple of these before working out.
I'm getting so swole right now. Oh, I think milk sugars, right?
Okay. Some galactoses and things like that.
Yeah, or lactose. All right, Dan. One thing I wanted to also do here at the top of the show was acknowledge our very generous Patreon supporters, Lynn and Arlen and Scott, who recently had donations that came through for the show.
Thank you so much. This is great.
Yeah, and if you want to support the show, we would be very grateful. And you can go to patreon.com/HelloPhD. And we've got some special treats for some of our patrons. So.
You can virtually buy us a beer.
That's right. All right, Dan, you ready to move on to some science in the news?
I am so ready. Let's do it.
Dan, you worked at a zoo.
That is true. When I was in 10th grade, I did work at a zoo.
Yeah, I think we've talked about this on a past show.
Yeah, because I was wearing I still own the shirt, and I still fit into the shirt, so I still wear the shirt.
That's right. Did you ever see animals poop while you're at the zoo?
Yes. Also, not at the zoo. I've seen animals poop. I do have 2 small children. They poop. A lot of things poop, Josh.
That's true, Dan. A lot of things do poop, and poop is very important. So animals discharge feces in a range of shapes and sizes.
Where are we going with this, Josh? And what does the zoo have to do with it?
Well, so a lot of the variation in feces from different animals has been used to track them or identify animals in the wild, but also in humans, bowel movements have been useful for diagnosing illness and generally keeping up with our health. Manure is produced in large quantities for use as fertilizer, and ironically, I just spread fertilizer on my garden about 2 hours ago, right before you got here. Some cow and chicken manure.
There you go. Yeah.
Yeah, so that's very timely.
I've seen chickens poop and I've seen cows poop. I'm just trying to make a list here since you asked.
Well, I'm tallying. We're up to about 17 right now. But you're not going to believe it, Dan. As important as poop is, here in 2017, we still know very little about the physics of how poop works, and specifically defecation, how the feces is ejected from our body.
Is that because nobody wants to put that on their CV?
Well, I don't know, Dan, but I have good news that the mystery has been solved, at least partly, in the most recent issue of Soft Matter.
That is not the name of a journal.
There's an article called The Hydrodynamics of Defecation, and it's scientists from Georgia Tech University in Atlanta. If we think about what we know about bowel movements from a physics standpoint, so often they're judged qualitatively and subjectively by their frequency and their appearance, such as their color, their shape, their size. And I'm sure you knew, Dan, in 1997, physicians Stephen Lewis and Ken Heaton at University of Bristol, they provided a typology of feces called the Bristol stool chart.
Now, you probably don't actually think I know about this, but I do.
So correct me if I'm wrong, Dan. I'm having this recollection when I read about this that we had a conversation at some point about the Bristol stool chart.
Yeah, we have talked about it. It was a topic covered in my program in physiology. We had to take medical physiology with the medical students. And so we got to learn about the Bristol scale. And if I'm recalling correctly, it goes from one level, which is like pure liquid, to another level where it's like hard chunks. And then you've got all sorts of descriptions in between that are not
Dan,
safe for radio.
To be more specific, it ranges from type 1, consisting of hard nuts that are hard to pass, all the way to type 7, which is a watery-like liquid. So
yeah, what's like a 4? Do you have that one?
I don't have all the descriptors, but I would really encourage anyone who's interested to Google the Bristol scale.
I think if you have kids, it's useful to have this scale, I think.
Oh, yeah, and I would say it's probably medically very relevant.
Yep.
But anyway, in this study, what the authors did was they combined some experimental approaches and theoretical approaches. And so they wanted to understand what goes into the physics of how feces is ejected from the body, and what are the differences among different species. So what they did was they examined defecation in mammals, ranging from cats all the way to elephants. They looked at 42 different species: warthogs, pandas, dogs, you name it.
Narwhals.
So lucky for them, so they're at Georgia Tech in Atlanta. So a lot of their research were measurements from videography from Zoo Atlanta and also dog parks.
Yeah, you get quite a few examples there.
The interesting finding of this paper that I thought was pretty cool was, despite and this is coming from the paper, this is a quote, Despite the length of rectum ranging from 4 to 40 centimeters, mammals from cats to elephants defecate within a nearly constant duration of 12 seconds.
Wait a minute. It doesn't matter how big the animal is, it's the same amount of time?
That's right. So it turns out if you're a cat or an elephant, this is something I learned, an elephant has an intestinal tract that is 10 times longer than a cat. However, the time of defecation, pretty similar.
Why? I don't understand. Why wouldn't it just take longer? Or you'd think peristalsis would be like a slower process. You got more time, more transit time because it's a longer path. No?
Yeah, well, they had a couple of reasons that they gave. One is the pressure is pretty consistent. The pressure in the intestine on the fecal matter is consistent across the animals. And also the aspect ratio of the fecal pieces is similar among the animals. One thing they also noticed was, turns out there are a lot of differences in the amount and the type of mucus associated with the feces. And so you might imagine a larger animal, the fecal matter moves much more quickly, and therefore there's a much higher mucus content that enables it to do that. One of the things they actually said was feces slides along the large intestine by a layer of mucus similar to a sled sliding down a chute.
It would really change the game of chutes and ladders, wouldn't it? Totally different experience.
So this actually came from their article. The main thrust of our work is
They didn't say that.
They said
There's
that.
a direct quote. I see it.
Yeah, the main thrust of our work is equation 8, which yields the time for defecation. All right, so
But you just told me it was 12 seconds. It's not an equation. T equals 12 seconds.
well, the way you come up with this is they actually came to the mathematical model of defecation. And if you want to know what it is,
I'm going to get this tattooed onto my arm.
you should. So the time of defecation is equal to the length of the feces divided by the thickness of the mucus times 4 times the length of the feces times the K value of the mucus divided by the diameter of the feces times the rectal pressure, all of that raised to the power of 1 over the mucus property.
So you can sit here and say, if we make the mucus layer thicker, then time goes down.
Mm-hmm.
And if we make the pressure higher, time goes down. Yeah, you can take this equation and actually make some sense of it. And what they found is that T is always equal to about the same thing.
Mm-hmm.
And so to compensate for the length of the different tracks, they had to increase the pressure or increase the thickness of the mucus. Makes sense to me.
Yeah, and there are a lot of evolutionary reasons
To the 1
for
over,
this.
what is N to the M?
So that's a mucus property. That
It's N sub
quantify.
M.
Yeah,
I
it
see,
is
I
N
see.
sub N. Yeah, N sub M. But evolutionarily, it's important for animals to defecate quickly because, in many cases, you're largely immobile during the act. Not to mention the smell can draw lots of unwanted attention.
There's not like a magazine rack next to the
Not
elephant?
that I know
No?
of.
Okay.
One thing I was interested in was I wonder if you divided the animals into predators versus prey, if there might have been some more subtle differences there. But
Yeah, and I would like to hear what happens when you get down to the mouse scale. Anybody who's worked in a mouse room or with rats, it's just a constant process of continuous pooping for those animals.
yeah, and as far as I know, the smallest animal that they looked at was a cat. But I would definitely encourage people to take a look at this paper. In addition to being interesting, it's very well written, and there are some little nuggets of.
You had to do it, didn't you?
Before we go, Dan, I have to.
Let's write the equation of our maturity level here. Minus 100.
Yeah, if you're really interested, so I was disappointed that this article is behind a paywall. If your university does not subscribe to Soft Matter, go back and listen to our Sci-Hub and the Publication Pirates.
We don't
episode.
condone that. Not condoned. But if it happens to happen, it's not our fault.
Well, one thing that did surprise me is what was not behind the paywall were some supplementary movies associated with the article.
And you're not going to make me watch them.
I can just show you one. One is a panda.
Thankfully, no sound on the video. That's a blessing.
Check out, it's a panda. A panda pooping. It's like a summer squash coming out of there. We should get one of these grad students on the show.
Thanks,
This is
Josh.
awesome.
Thanks, Josh, for sharing that
All right, Dan.
amazing science in the news.
All right, now-
What news are you reading?
And now no one is left to listen to the Science March. I was really excited.
I can almost hear the unsubscriptions as the clicks happen.
Seriously, though, this was a really fascinating paper. All right, Dan. I had the privilege of attending the Raleigh Science March a couple weeks back.
You went. Good.
I went, yeah, and it was really fantastic. There was a really great crowd there. Lots of scientists, lots of passionate people. And one thing that was just really cool was I was running a little bit late, so I was driving into downtown Raleigh, and the crowd had already started the march part. And so they were all marching from a university downtown to this park where the rally was going to be. And so my car was stopped at a stoplight, and there was just this huge line of like scientists, and they kept coming, and they had the signs. I felt oddly inspired. I almost felt like this tear welling up in my eye of all these people who were out there because they love science. And I don't know. It was very impactful for me.
So you actually got to witness the march, and then you went and participated?
I did, yeah. So then found a place to park and came over to the rally.
You were late, by the way.
Well, I was late, but there were so many people there that I kind of came in the back way, and people were still arriving. But one of the things I did, Dan, was I brought my recorder with me and thought I would just talk to some people and find out who they were and why they were there.
Awesome. Well, can we listen to some of the audio?
Yeah, let's take a listen.
My name is Ashley Mattison. I live in Chapel Hill, and I own a business. And I'm here because I have children, and I think that cutting funds for science education is absolutely insane. And more importantly, I'm here because I believe that our policies coming out of the NCGA and out of the United States Congress should be based on evidence and data, not on ideology and faith.
Excellent. Can you tell me what your sign says?
Sure. It says, English majors for evidence-based policy making. We all have a stake in this.
My name is Mike Dolan-Fliss. I'm an epidemiology PhD at UNC. And why I'm here, science and social justice both have a complicated but important relationship. You know, science has been a perpetrator but also a supporter. And so being more woke is important as a scientist.
My name is Nancy Scott. I work in environmental consulting. And I do a lot of work in streams and see how much humans impact aquatic ecosystems. And I'm here because I want fact-based decision-making to be the norm, and for people to think outside of just like their everyday and think about the environment and the earth.
My name is Rita Tamayo. I'm a scientist, a microbiologist at the University of North Carolina, Chapel Hill, and I'm here to represent. I brought my two daughters who are also math and science enthusiasts, and so we're here to join the crowd.
My name is Preston Countryman. I'm a postdoc at NC State in biophysics research, and I'm here to just promote science awareness and that it's important. You can't pick and choose what science you like.
How are you? And best dressed at the science
Thank
festival.
you. Yeah, I'm Colleen Countryman, and I'm a professor of physics, and I'm dressed like Miss Frizzle, and I want to make sure people are thinking critically, and so I'm hoping to inspire kids to do that.
I'm Brandon Long. I'm a physics candidate over at NC State. I'm here to promote American science as much as can.
Hi, my name is Patrick Charbonneau. I'm a faculty in the chemistry department at Duke University. I'm here for the first protest I ever participated, the first march I participated in my life, because I feel that the tone of a conversation about science makes me very uncomfortable. I'm left with the impression that all the things I believe in are being left aside, and I think we're all in the worst for it.
Hi, I'm Raquel Salinas. I'm a postdoc at Duke University. I work in the Office of Biomedical Graduate Diversity. I'm here at the Science March for two reasons. One is that I want to ensure that we have a future in science for everybody, that the public knows how important science funding is, and that it's a diverse and inclusive place for all of our scientists.
Hi, this is Devin Gillette. I am the IMSD director at Duke University, and one of the reasons I think it's important for us to be here today is just because we want to make sure that we have a really strong visual about why it's important to be put science at the forefront. You know, all of us are individual. We have our own backgrounds, our own life experiences, but we're really brought together and unified by our love of science and our realization that it's important for us to continue to fund, support, and encourage research so that all of us, dependent of your background, have an opportunity to engage.
My name is Laura. I'm here because I consider myself to be a scientist, even though I'm not currently employed as one. I'm here because I think science is the thing that's going to save the planet, like climate change and medical research, clean air, clean water for everybody. I mean, I don't have an answer more than I just think it's the single most important thing that we can do as a species to make the world a better place.
What does your sign say?
I have one side that says, fund the EPA, there is no planet B, because we don't have another option, and the EPA is the best thing we have going on that fight right now. And then I have Make America Think Again.
My name is Megan. I'm a registered veterinary technician, and I'm here because I believe in preserving the environment. I think it's very important.
Awesome. What does your sign say? You got a lot going there.
Climate change is real. Alternative facts are not. Keep your tiny orange hands off our planet. The other side says the CO2 levels are rising, and so are we, peacefully resisting.
I am Jen. I am a chef, and I love science my whole life. Just here supporting a good cause.
Carrie Thomas, faculty member at NC State. I'm here to support science and raise visibility.
Lisa Pike, I teach biology at Francis Marion University in South Carolina, and I brought my daughter, and I wanted to show her that there are a lot of people out there that actually understand and support science.
Awesome.
Want to say your name?
Who are you?
Lucy Pike.
And why are you here?
To support science.
What does your sign say?
It says, show me the evidence.
I love it. How about you?
I'm Joey Thomas. I go to Ligon Middle School, and I'm here to support science and global warming because some people don't believe in it, and then soon Florida's going to be underwater, and then Disneyland will be washed away.
My name is Meredith. I work at an educational nonprofit, and I'm here because Donald Trump pisses me off about climate change, and I want to make sure that people know about it and that more people know about science and that it's real and not just opinions.
So tell me what your sign says.
It says, the good thing about science is that it's true whether or not you believe in it, and that's from Neil deGrasse Tyson.
I'm Alexandra Boyd, and I teach high school physics, so I'm out here to help kids experience science.
Nice. How about you?
My name is Alex Boyd. I'm here to support my wife as a teacher, especially in the science field, and with everything going on, just think it's kind of important to raise awareness around science and everything that it does for us.
I'm Delara Sen. I'm a second year PhD candidate in chemical and biomolecular engineering at NC State. And why am I here? Because I think science shouldn't be related to politics. Like what we're doing in a lab is not political. We're just trying to help people. We're just trying to make the world a better place for everyone.
That was inspiring. I mean, it was so many optimistic and yet proactive, probably a little bit concerned about the current state of affairs, but those people are doing something about it. They must believe that there's a path forward.
Yeah, I mean, a common theme was people really wanting more fact-based decision making.
Why is that controversial? Am I missing something? I feel like argument has existed for a long time, and the only reason we make arguments is because we think that it presents the truth, right? And every side of any debate tries to argue. So I mean, wouldn't we all strive for that?
I'm trying to think what the converse of fact-based decision making would be. Fiction-based decision making. I don't know. But another thing I thought was cool, Dan. A few of the people I talked to, it wasn't just the scientists themselves, but they had their kids there, and very, very festive atmosphere, and actually it wasn't all scientists.
I heard music in the background. Somebody was playing some jams.
There was some music. One of the people I spoke with was a business owner and a mom, an English major. I talked to a chef.
And so it wasn't confined to people that were actively working in labs. It was people that are, I guess, supporters of science, that value it, that get something out of it.
Yeah, absolutely. And, a common theme that I saw in a lot of the signage and the people I talked to was that this notion that, hey, science is not just for us, the scientists, but science really is for everyone. Anyone can do science. Anyone can think scientifically, think critically. And that was a common theme I saw. And that was something I felt inspired to do, especially, as I mentioned this past week, being out in the community, talking to people about science. I think it's so important. The march was great. But I think what we do after the march is what's going to be even more critical. And a big thing that I'm trying to take to heart and spread to others is the importance of being visible as scientists, not just be these mysterious creatures that are cooped up in our labs, but we really need to be out there. Because, one thing that I thought was pretty neat, seeing all these people who are scientists, they're so diverse. They're just normal people who happen to do science for a living and are passionate about it, but regular folks.
Well, and that's not going to be the default. Nobody who's working in the lab thinks, oh, I've got tons of free time. Let me just go out and tell people about science and be accessible. I think most of us are busy. Many of us are introverts. And so our path of least resistance is to kind of sit quietly and not raise our hands. But what you're saying is we've got to do something more than that.
Absolutely. And I think, and I've fallen guilty to this too, especially as graduate students, as postdocs, we work on these projects that can be highly specific. And so I think, and highly technical. Yeah. And I think we can tend to get in this mindset that, well, I can't really share this because it's either A, not interesting to anyone other than me in my lab, or B, just the effort required to try to explain it is just not worth it. Like, the cliche example is when your grandma at the family reunion says, so what do you work on?
Yeah, I work on amino acid number 238 of this protein, Grandma.
But I think what's important is, and maybe a challenge to all of the scientists, to all of us, is we need to think not just about the technical details of what we're doing, but really maybe even practice, like write out, what's the big picture of what I study? What's the importance to society, or what's the importance to humankind in general of the work I'm doing? I guarantee there is some, because the work you're working on is probably funded in some way, or someone had this idea. And so, that can also be a motivating thing, is to really keep in mind the big picture of what you're doing.
Yeah, and I believe strongly in being an interpreter of science generally for people. You'll work with somebody who has a question about some new fad diet. And if you have studied physiology, even though it may not be specifically in that field, you can probably collate some of the literature and not present them with a bunch of papers, but say, hey, did you know that a low-fat diet actually doesn't lead to better health outcomes, that these other factors play a more important role? And it's bringing the science that's hidden in PubMed to most of the world. I would argue nobody but you has heard of PubMed if you're a scientist.
Yeah.
And so being an interpreter, it's like being a docent at the museum. It's taking what you can learn, even if it's not your specialty, and translating it to everybody else.
Yeah, and that is so important. Along those lines, Dan, one of the last people I spoke with was this guy who was a fellow at Duke who was a cancer researcher, and he was working to help train the immune system to kill melanoma cells. And it was a pretty hot day that day, and he was sitting out at a table in the sun, and he had a sign that said, "Teaching the immune system to kill cancer, ask me anything." And he was just sitting there, and people from the public were coming up to him, and he was just telling them about not only his research and why it was important, but also the importance of funding research so we could learn things about cancer and come up with better treatment.
My name's Nick DeVito. I'm an oncology fellow. I work at Duke, and I work at a tumor immunology lab, mostly on melanoma and lung cancer. And while treatment of cancers by using the immune system has made huge strides recently with drug approvals and everything from bladder cancer to lung cancer to melanoma, still most patients don't respond to those immune checkpoint inhibitor drugs that take the brakes off the immune system and allow your immune system to attack a cancer. And our lab seeks to find out why that is, that most patients' tumors don't respond, and how these tumors are continuing to evade our immune system so we can develop better treatments for our patients. The main reason I'm out here is because our lab and many other labs doing this work depends heavily on funding from the National Institutes of Health. Private funding, such as that from philanthropists or from organizations or from drug companies, simply isn't enough, and it may not be the right venue for us to receive funding to do really good discovery-based research and further the field so we can have more treatments for our patients and kill more cancer, the immune system. So that's why I'm here, man.
We talk a lot about got to convince the politicians that science is important because they control the budgets, and that's true. But it's really the public. Those are that's who's funding the majority of our research.
Yeah, create demand and take it to the next level. So giving out information, step one. Getting people to understand the scientific method. So let's say they ask a question that you don't know the answer to. You can have a conversation about, well, that's unclear right now. How would you figure that out? Like, what test could you do to find out the impact of this on your diet, or what test would you do to find out how to cure this particular disease, or what is it that makes cancer so hard to kill, and have them think through it and think like a scientist. I think it'd be really valuable. We talked about scientific literacy. This is exactly what it means. Yeah, involve people in the process. I think I might have mentioned this on a past show, but something that hit me probably a month or two ago was, I was reading something. It was a debate about climate change or vaccines, and I was listening to an interview or seeing a comment from someone who was really skeptical, not buying scientific consensus, the thing a scientist was saying. And I realized there's a misconception sometimes among people about what the scientific process is like. Not necessarily the scientific method. I think we learn that in school sometimes. We learn about scientific findings, but that, by the time we get to a point where we have a finding, a published finding, let alone a scientific consensus, it's not just one person's opinion, but it's likely gone through, okay, I came up with a question, then I designed these experiments, then I repeated them 50 times, and then I got a result, then I presented those results, and then the audience tore me down and gave me critical feedback, and I went back to the drawing board, and then I wrote it up for publication, sent it to some more scientists who then critiqued it some more, and maybe had to do some more experiments. So really by the time we get to a scientific finding, it's not just one person's opinion, but it's been dozens of people who have sort of molded it and put their feedback on it. It's a long-term process. Right, and that doesn't mean that no errors creep in, of course. But I think what you're saying is, if you want to be a skeptic, your protest cannot be nuh-uh because I don't like that. Your response has to be, did you consider X, Y, and Z that might be impacting your results? And then together you and I can come up with a way to test X, Y, and Z and prove that they either are or not having an effect. Yeah, and the beauty of us as scientists is we welcome that. We're used to that. That's what we do every day. I mean, actually, one thing that always cracks me up is sort of these conspiracy theories that scientists are all colluding together to come up with some fake data. Smoking cigars and leather seats in a back room somewhere. I'm like, you have never been to a scientific seminar before, because everyone is just sitting in the audience licking their chops to try to come up with that one question that breaks through the... Trick the sheeple. I mean, you probably remember as a grad student, what's the part of the talk you're most afraid of? The questions. Don't ask any questions. That's right. Oh, yeah, the last thing I wanted to mention that stood out to me was the faculty member who mentioned that this was his first march, his first bout with activism. And I thought that was true for me too. I had not been to a protest before or anything like this. And, I thought that's what was pretty interesting, is there's something about what's going on now that was so compelling that all of these individuals who probably had not considered getting out on the street on a Saturday with signs to actually go out. And to me, that's something. So if you, people listening to this podcast, went to your local science march that happened a few weeks ago, or maybe you went to Washington, D.C., and you have pictures or you talk to people, let us know about it. You can email us, podcast@hellophd.com. You can tweet to us @hellophd. And I would love to just collect some of these things, maybe share them. We can add them to these show notes and get a feel for how it looked across the country. Yeah, and I'll post a photo of some photos of some of the people that I talked to and some of the cool stuff that I saw. But it was just such a great, festive, happy atmosphere. I don't know. It was pretty neat. Do we have a word puzzle? Do we do that? We do. I got my act together. All right. Let's hear it. This clue comes from some examples of my life, but here's the clue. Creatures in this phylum have a painful sting like falling into a patch of nettles. I'll read it one more time. Creatures in this phylum have a painful sting like falling into a patch of nettles. Remember, I'm looking for a scientific word described by the clue, and once you get it, you'll find the literal meaning of that science word is a phrase in the clue itself. If you think you have the answer, email it to puzzle@hellophd.com. We'll randomly select a winner from all the correct responses and send the lucky puzzler an Amazon gift card. All right, Dan. Thanks for that. All right. We'll see how many responses we get. And Josh, thank you for the Nitro Milk Stout from Left Hand Brewing. I always used to wish that I was left-handed. It's great. I'm left-handed. I always had this viewpoint, left-handed people are smarter. It's true. I've proven it. You are the brains of the operation. That's right. Exactly. All right, Dan. We'll see you next time. See you next time. Oh, the one thing I want to tell you.
So the gentleman I talked to who said it was his first march, you'll never guess what his sign said.
This is my first march?
It said, soft matters.
No, it did not say that.
Yes, it did.
What does that mean?
Oh, I have a photo.
I think you're making this up.
I'll tell you in a minute. I'll show you in a minute. How funny is that?